Some people might say, if natural selection is so good, how come we do get old and die anyway?
Oh my goodness, that's how I got into this business, Richard. I don't know if we've ever talked about that. But when I was a sophomore as an undergraduate, I asked myself the question, why didn't natural selection make us live longer? And it should, I was convinced as an undergraduate, because there's a lot of genetic variation in how long you live. And since we know that different genes can make you live longer, why didn't natural selection increase the frequency of the genes that make you live longer? But instead, no. Most people are dead in their 80s, and everybody's basically dead by age 100. I came up with what I thought was a fabulous explanation. I thought that it was very important for the species to get rid of some individuals so that the whole species could evolve and adapt to a changing environment. And my professor said, "That's brilliant, Nessie. You have a good biology brain."
He didn't.
He did say this, but it was very shortly, actually, George Williams has published his book.
I can't help feeling that if you'd gone to Charles Darwin rather than to your professor, he would have said something like this: but it's reproduction that really matters. Individual survival is only a means to the end of reproduction.
You know, I didn't ever learn that, even in my evolutionary biology course at college. I don't know why. People talked as if living healthy lives was what natural selection shaped. But of course it doesn't. It shapes maximizing reproduction. And if that makes you live a shorter lifespan, too bad. That's what happens.
So if you reproduce like crazy for a short time and then die, you've done better than somebody who doesn't reproduce very much and lives a long time.
Indeed, indeed. So when I was in medical school, I stuck up my hand and I said, "So, Professor, why do we age?" And they said, "Well, it's because machines break, that's why." And I said, "No, why wasn't natural selection better about this?" And they said, "You don't understand. It's genetic. There are mutations. Things break." I said, "Well, maybe." After I finished medical school, I started hanging out with evolutionary biologists at the University of Michigan, including actually Bill Hamilton and Bobby Lowe and a lot of other great people. And they immediately said, "You're a doctor and you don't know George Williams's theory about aging? You're ignorant." I said, "No, I've just gotten the best medical education you can get." And they said, "No, you don't know anything." So I read that paper of his from 1957, and I realized that I'd been completely wrong about aging, even though I was deeply interested in it for 15 years. And then I did a study looking at how strongly aging influences survival and reproduction for humans now. And here's a simple calculation I did. If there weren't any aging, how long would we live? It's very easy to do. You just assume that everybody, you know, your likelihood of dying goes up as you get older. That's really what aging is. What if your likelihood of death stayed the same throughout your whole life as it is at age 20? About a third of us would live to 1,000 years old. That makes it really dramatic. So now we come back to George Williams' explanation. Take a gene, he said, that makes your bones heal more quickly. It changes calcium just a little bit. It would be selected for, because you break bones early in life a fair amount, and healing them quicker would be a good thing. What if that exact same gene had a different effect that deposited calcium in your coronary arteries? What if that killed everybody by age 120? And he noted, too bad. If it gives a selective advantage early in life when lots of people are alive, that gene is going to become more frequent, even though that same gene eventually kills everyone. Once I realized that, I started realizing that I wanted to understand every aspect of the body from an evolutionary viewpoint, trying to figure out why natural selection didn't do it better.
You sort of feel that if doctors could get that one point, everything else would follow. It's a rather a profound point in a way. I mean, another way to put it would be to say that a lethal gene, or a gene that makes you die when you're young, is never going to get into the next generation. But the very same gene, if it has its bad effect a bit later,
right,
it's got a better chance of getting to the next generation. Right. And if it doesn't have its bad effect until you're 100, then it's going to get through all the time. And so we are a kind of walking dustbin of late maturing lethal genes. But if any of us had a gene that made us die young, well, none of our ancestors had a gene that made them die young.
And indeed, yeah. How many of your grandparents died before reproducing, Richard?
Yeah, very good point.
Right.
What about mental health? Can we bring Darwinism to that?
We certainly can. And many people imagine that it's just them and their family that have problems with depression, alcoholism, anxiety, and schizophrenia and the rest. Oh, no. The World Health Organization data shows that, especially for women of reproductive years in modern countries, more than half of all of the medical disability and early death is from mental problems, mainly depression and anxiety disorders. But let's take anxiety for a second. Wouldn't it be great if we didn't have any anxiety? If we were just completely relaxed and mellow all the time? Except that we wouldn't have prepared for this program at all. We wouldn't have done our studies. But it's worse than that. Imagine if we were at a watering hole in Africa, well before anybody learned to read. A lion comes by, and we run like mad. But there's some variation, isn't there? Some people run at the least hint of a lion. Some people run when the lion's coming near them. And other people don't run until the lion is right on top of them. And you can see where this is going. The ones who run away when the lion is a long ways away never get any water. That's really bad for you. The ones who wait until they can smell the lion's breath often become lunch for lions. It's those people in the middle who do best. But now we're back to the smoke detector principle. Imagine you hear a sound behind a rock at that watering hole. How loud does the sound have to be to make you run away? You don't know whether it's a monkey or a lion. How loud does that sound have to be? And you can actually calculate just how loud it should be. If the cost of running away is, say, a couple of hundred calories, and the cost of not running away if that sound comes from a lion is 200,000 calories, then you should run away whenever the sound indicates that the probability of the lion being there is greater than 1 in 1,000. This means that the majority of times you have a panic attack and run away, you won't need to. But it's still perfectly normal. I treat patients with panic attacks quite often. It's a very treatable psychiatric problem now. And I had never really grasped what was going on until I took this evolutionary view and realized that the whole system was shaped by natural selection to go off with many false alarms. And that's why we're all so prone to anxiety that it really doesn't help us most of the time.
And some people have their smoke detectors tuned a little bit more risk-averse than others.
They certainly do.
Yes.
And they have advantages as well as disadvantages. My patients find this wonderfully empowering. They've always thought that they were just anxious people who weren't as good as other people. And when they finally learn that, in fact, they have real advantages over other people because they're more sensible in some ways, that helps them quite a lot.
I was going to ask about that because a lot of what you're saying is explaining why we go wrong in these ways. And I was going to ask you, how does it actually help to cure people? And you've just given one reason, which is that your panic attack patients actually are comforted by having the explanation given them.
Not only comforted, about 20% of them get cured.
Get better, yes.
Yes, and previously they would say, I think it's cancer, doctor, I think I have a brain tumor, I think I have heart disease, and I would say, no, 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 the test showed that you don't have that. And they'd say, yes, but I still could. But they didn't really understand what panic attacks were. Once I started saying, listen, panic attacks are false alarms in your getting away from lions system. And because they're false alarms, running away and getting out of the store doesn't do you any good. In fact, every time you get out of the store and run away from your own anxiety, it makes it worse. About 1 out of 5 patients says, oh, now I know what that is. I'm just going to ignore it. And they go about their lives and are not bothered by panic anymore. Very, very practical.
I suppose one could say, well, but there aren't any lions. I mean,
nowadays it's not all that useful, although we still do have fatal kinds of dangers sometimes. Not lions, but more likely other people and other kinds of dangerous situations.